magnetic field lines. The black circle at the center wears a thin ring of lensed light, a distorted promise that everything luminous behind it has been bent. Radiation eats chemistry for breakfast. Atmospheres puff, upper layers haze, molecules fracture and recombine into photochemical soups that rain hydrocarbons. If the world carries a magnetic field, its motion through magnetized plasma turns it into a giant unipolar inductor, driving currents that close through the surrounding sheath and ignite auroral ovals with energies that make Jovian displays look like candlelight. Pericenter is a storm season and an electrical season and a geology season, all at once. Whether the globe survives depends on the knife edge between gravity and material strength. The tidal radius for an Earth mass body near a multi-million solar mass monster sits of order half an astronomical unit. Dip inside that and the planet unthreads into a stream. Go too far and the debris becomes a luminous ribbon, wrapped into a tight ring by differential gravity, shock-heated where the stream intersects itself, and then bled into the inner flow as dust and gas, an appetizer for the central furnace. Skirt just outside and the world lives to loop again, losing a little orbital energy each time to tides within itself and to interactions with the ambient medium. Over many circuits, the needle ellipse shortens and fattens toward a tighter path. For small bodies that process is glacial, but the direction is one way unless another kick intervenes. Detection is a game of patience and cleverness. There is no host star to dim with a transit, no reflected sunlight to flash at opposition. Instead, astronomers would look for periodic infrared brightening as the surface or atmosphere is heated at closest approach, for submillimeter or radio bursts from induction-powered aurora, for faint, transient dust arcs if volatile ices sublimate and condense into rings that glint at certain viewing angles. The timing of those flares, together with their relativistic clock drift as the pericenter precesses, would betray the mass and spin of the central attractor. In a well-watched core, the bustling downtown of this island universe, precision astrometry could even catch the gravitational tug of a planet mass body on nearby test particles, the way the famous S-stars chart the central gravity but on tinier scales. Chemistry on a captured nomad is written by extremes. With no daily sunrise, the default climate is stratified and slow, but pericenter injects oxidants, nitriles, and radicals that never see equilibrium. On a rocky world, magma ponds erupted by tides may glass over between passages, preserving layers like tree rings that encode the timing of each dive. On an icy colossus, methane clouds could seed hydrocarbon snow that is erased on the next furnace swing, a periodic resurfacing cycle that paints latitudes by orbital phase. If a thick hydrogen envelope exists, pressure broadening and collision-induced absorption can warm the deep troposphere into habitable temperatures even in the cosmic night. Add tidal power and you have a laboratory for life that ignores suns and worships gravity. Habitability here is not a soft meadow under blue sky, it is a dark ocean under ice, keeping its own calendar by the beat of spacetime. Dynamics in the central precinct of the star archipelago never rest. Resonant relaxation rattles orbital orientations as passing stars exchange tiny torques. Correlative cycles driven by the cluster can pump eccentricity higher and inclination stranger. A brush with a compact object can tilt the ellipse into a new plane. Gas streams drifting like luminous smoke can sap or donate angular momentum depending on the geometry, sometimes herding small bodies into families of similar paths that share a preferred pericenter direction. The vagrant story is therefore not just one world and one well, it is a swarm problem, a statistical ballet of millions of pebbles, rocks, comets, and planets responding to a central verdict. Seen from far above the disk of this stellar commonwealth, a captured wanderer is almost nothing, one more dust mote obeying the deepest gradient in town. Seen up close, it is a world with seasons defined by relativity, weather written by particle physics, geology set to the rhythm of a rosette, and chemistry that remembers every encounter with the photon furnace at the core. If astronomy's usual questions begin with, "What star does it orbit?" these nomads flip the script. They orbit a geometry more than a lamp, a piece of spacetime that sculpts orbits into flowers and time into spirals. The city around them, this spiral dominion, this star-crowded burrow, this luminous archipelago, provides the crowd noise and the occasional shove, but the dance belongs to gravity and whatever stubborn sphere refused to be unmade. Say the word, and the story dives deeper, into how the precession angle maps the mass quadrupole of the central engine, how ring systems survive the torque at pericenter, how a cryovolcanic plume would look silhouetted against a lensed background, how a world can be nightbound and still warm, how Capture writes its signature where even the brightest suns are only scenery. Capture has a dozen doorways and each opens with a different creak. A common route begins with a planet tethered to a star that wanders too close to the dark turbine. Tides tear the system apart, flinging the lamp outward while the smaller companion is left behind in a thin, feverish ellipse. Another path starts even farther out, where this island of stars teems with binaries that swap partners in gravitational bar fights. A three-body ricochet can rob the drifter of enough energy to fall into the core's jurisdiction. Add in the gentle drag of thin, magnetized gas that threads the downtown of the starry republic, and a small body's fate shifts from visitor to resident. The end product is the same, a path with a Aphelion in the quiet suburbs and a pericenter drawn so close that the world tastes curvature. The physics of that taste is ruthless and precise. Tidal stress rises like a cliff as closest approach shrinks, scaling roughly as the inverse cube of distance, so a small change in pericenter means a large change in pain. Well outside the event horizon of a 4 million solar mass engine, a rocky globe still meets a survivable corridor. Just inside roughly half an astronomical unit the Roche calculus stops being polite, and mountains become molecules. If composition leans icy, the safe lane is wider. If iron-heavy, the world holds together longer but bleeds heat with every flex. The energy pumped into the interior during a single dive can exceed Earth's global geothermal budget many times over, and that power does not distribute evenly. Weak layers decouple, partial melts pool at depth, fault zones unlock for a few frantic days, and then the long freeze of Aphelion begins anew. Relativity rights flourishes on top of Newton's grammar. Each lap, the argument of pericenter marches forward, so the track is not a closed ellipse but a rosette whose petals open by tens of degrees per orbit. If the central spinner's axis is tilted, frame dragging also nods the orbital plane, a slow corkscrew that depends on the black hole's spin and quadrupole, exactly the combination needed to test the no-hair predictions of gravitation theory. Even a planet is a clock, comparing the timing of heat pulses, induced aurora, or dust outgassing from successive pericenters against a relativistic model constrains the central mass and spin the same way the S-stars do, only with a colder, smaller, stranger probe. What bathes the surface at closest approach depends on the central furnace's mood. In a quiet nucleus, the photon bath is thin and hard, rich in X-rays and ultraviolet that carve chemistry rather than warm oceans. During flares, luminosity can spike and the energy flux at 1 astronomical unit rivals or surpasses a sunlit day. That turns atmospheres into laboratories, hydrogen envelopes puff and cool into hazes, nitrogen-oxygen mixes spawn nitrates and peroxides, methane skies polymerize into smog that snows when the world coasts back into darkness. A magnetic shell amplifies the drama. Motion through the core's magnetized plasma turns the globe into a dynamo, currents close along field lines, joule heating adds to the tidal budget, and polar ovals become brutal, flickering crowns that inject chemistry into otherwise sterile air. If the traveler carries a ring system, the pericenter ram pressure warps and may even twist it out of the equatorial plane. Resonances can drive ripples that march around like barcodes a spacecraft could read from orbit, if any spacecraft could survive the trip. How would the luminous archipelago betray one of these hidden citizens? Start where the signal is most honest: heat. Near-infrared light curves that swell and fade on the orbital timescale would be smoking guns, especially if the peaks creep earlier each year by the amount predicted from pericenter precession. Sub-millimeter flashes from induction-driven aurora would ride atop that cycle like percussion accents, and in fortuitous geometries a thin dust wake, volatile grains boiled off at pericenter and sheared into a filament, might backlight against the crowded star field. Precision astrometry in the central parsec already traces the ballet of bright test particles, a planet-mass body would be subtler, but in aggregate a population would add a small, correlated noise to orbits of nearby tracers that a patient interferometer could isolate. On the gravitational wave dial, a rock looping at a few tenths of an astronomical unit around a monster is too quiet for current ears. A super-Earth pressed into a tighter, faster rosette around a more massive dynamo could creep into the lowest bands of a future spaceborne antenna, whispering an extreme mass ratio murmur at millihertz. Origin stories matter because they leave scars. A world stripped from a star within this spiral dominion might keep a residual moon, and that companion can act as a heat valve, pumping eccentricity and modulating tides the way Io and Europa share energy. A body formed in the cold outskirts of the stellar continent, then scattered inward across kiloparsecs, would arrive rich in volatiles and poor in refractory crusts, favoring ocean underice outcomes and atmospheric hazes. A fragment of a shattered super-Earth might come preheated and metallic, its magnetic shield strong and its surface bare. Some vagrants will finish as streamers after one unlucky dive, others will circularize into close-in embers that feed dust to the central flow, and a stubborn few will surf the knife-edge corridor for millions of years, carving a private calendar into rock and ice. Between passages the night is honest and slow. Without a sun, climate is a negotiation among internal heat, blanket gases, and radiolysis by cosmic rays. Hydrogen-rich mantles can push deep tropospheres to temperate pressures and temperatures even in darkness. Add tidal kneading every few months and a subsurface ocean becomes not just likely but vigorous. Life, if it cares only for gradients and solvents, could regard the whole nebular conurbation as a sky it never needs. Metabolism chews on oxidants laid down in storm seasons and waits out the cold. Biosignatures would be paracenterphasic, bursts of trace gases that rise, react, and fall on a schedule written by gravity, not daylight. The surrounding star-packed burrow never stops meddling. Resonant relaxation nudges orientations, causative pumping from the wider cluster can trade inclination for eccentricity, occasionally pushing a survivor into the red line where one more degree of freedom means disassembly. Passing compact remnants, neutron stars or small black holes, offer impulsive kicks that can flip the ellipse or eject the traveler altogether into the deeper halo of the stellar commonwealth. Thin streams of gas drifting like pale smoke near the core can sap energy at some true anomalies and donate it at others, herding small bodies into families with shared pericenter directions, ghost belts that a sensitive telescope might map as repeating arcs of dust. Endgames are varied and theatrical. The unlucky shred into a luminous noodle, the modest settle into warm embers that paint the inner flow with fine solids, the rare bold few spiral inward over eons as tides and drag eat angular momentum, flirting with orbits so tight that relativistic beaming would turn the world's nightside into a time-varying lighthouse. Somewhere in the ledger of this deep sky province there must be a limit case, a super-Earth that schemes just outside the last stable path, lit not by a nearby lamp but by spacetime's violence, wearing auroras brighter than continents and an ocean that boils sideways only 1 week in every 100. That, too, is a planet, night-bound, time-scarred, tide-fed, owed to the same rule the whole stellar federation obeys: fall toward the deepest place you can find, and call whatever survives a home. Over long stretches the captured world becomes an archivist for the whole Star City's center. Each near miss with the abyss right separate, datable layers, a veneer of nitrates frozen after one bright storm season, a cracked dike where tidal heating forced magma into brittle rock on another loop, a lacy deposit of tholins laid down when ultraviolet flares ran especially hot. Ice shells remember in stratigraphy, rocky crusts remember in stress shadows that only relax during the far-out winter. Even the core keeps time, because tides pump energy at discrete harmonics of the orbit and those harmonics drift as relativity slowly rotates the ellipse. A geophysicist dropping a seismometer here would be reading the ephemeris of spacetime, not the calendar of a sun. Close Passage has its own weather. The planet plows through dilute but angry plasma threaded by magnetic fields. The flow wraps into a comet-like magnetotail and a bow shock grows ahead of the nose where neutral exosphere gas meets relativistic wind. Sputtering and charge exchange carve atoms from the high atmosphere and turn them into a faint, elongated cloud that the next orbit shears into a filament. If the globe carries rings, ram pressure kinks their edges and differential precession winds them into spirals. Self-gravity and collisional damping then rebuild order between passages, like a record that warps in heat and then flattens under its own weight. Moons complicate everything in beautiful ways. A small companion can pump the big body's eccentricity, modulate tidal heating on beat frequencies, and see transient arcs of dust that flare in forward scattered light as the pair schemes the inner glow. Energy bookkeeping sets the long arc of fate. Tides within the world steal orbital energy and stash it as heat. Tides raised on the central giant don't matter, but tides raised by the planet on itself do. The conversion efficiency depends on the love number and quality factor, how deformable and how lossy the body is. Rubbery ice shells and partially molten mantles turn orbit into warmth better than rigid iron. In dusty inner gas, hydrodynamic drag dozes along, shaving a little velocity each pericenter. Over many circuits, the path shortens and rounds, the pericenter lifts, and the heating softens. Some refugees eventually settle into warm, near-circular tracks in the inner glow where they become stealth heaters of the local medium, shedding fine solids that drift inward and thicken the luminous fog. Others never calm down. A perturbation from a passing remnant or a secular push from the surrounding cluster ratchets the eccentricity upward until the safe corridor narrows to nothing and the world shreds into a ribbon. The ribbon stage is its own astronomy. Tidal debris lifts into a thin stream whose inner parts race ahead and outer parts lag, where the loop closes on itself, self-intersections shock and light the gas, and a broken ring forms that slowly feeds the central engine. Dust grains sputtered from the stream pick up charge and feel Lorentz forces, painting the inner precinct with faint, polar-aligned brushes. If any of that debris crosses our line of sight to a bright background tracer, the light curve would show multiple, sharp-edged dimmings spaced by the stream's thickness and the ring's precession. The geometry would be a decoder ring for the mass and spin of the core and a post-mortem for the world that didn't make the cut. Between catastrophes, biology has room to try things. A hydrogen-rich cloak can push the deep atmosphere to temper pressures even in eternal night. Add ammonia, methane, and water and you have a chemistry set that resets at each fiery swing but never fully erases. In an ocean sealed under ice, pressure-induced clathrates and antifreeze salts can keep brine liquid while tides stir it like a slow piston. Oxidants laid down during auroral seasons diffuse into the dark and feed redox metabolisms that care about gradients more than skylight. If anything living evolves timing, if enzymes anticipate the hot week by upregulating repair pathways and membrane chemistries before the plunge, it would be a life that reads gravity as weather and relativity as calendar. Signals for telescopes must be chosen where the contrast is kind. Thermal emission is honest. Pericenter spikes in the mid-infrared, decays over days to weeks with a tail set by heat capacity and circulation, and returns on schedule with a phase that creeps as the ellipse rotates. Polarization is a second handle. Forward scattered dust from a transient ring produces a polarized flash that peaks slightly before the thermal crest, and the offset grows if the ring is tilted by frame dragging. Low-frequency radio from unipolar induction sets a clock that jumps when the magnetosphere reconnects. Line emission from sputtered neutrals, oxygen, carbon, sodium, traces the exosphere's size and tells whether the atmosphere is being eroded or merely roughed up. A handful of orbits, modeled together, would weigh the central anchor, test for spin-induced nodding, and even hint at the traveler's interior through how quickly it turns orbit into heat. Capture demographics are written by the wider star continent. Barred systems funnel gas toward their hubs, thickening the medium and boosting drag capture for pebble-to-comet scales, while rich nuclear clusters elevate the rate of three-body exchanges that can swap planets off their host lamps. Ellipticals with giant central engines have bigger safe lanes for rocky bodies. The event horizon is larger but the tidal radius scales more slowly, so some retain captured super-Earths that skim within a few tenths of an astronomical unit of the rim and light up like lanterns at each dive. Dwarfs with small cores are harsher, the tidal radius shrinks until rock must venture so near that survival becomes unlikely and ribbons are the rule. Different neighborhoods breed different fossils. Navigation through this inner ward is a textbook in subtle torques. Resonant relaxation trades angular momentum among orbits with similar energies, random walking the orientation in a way that can be faster than two-body scattering. Correlative cycles from the broader cluster tilt and stretch paths, sometimes stalling at high inclination where pericenter distances hover near the danger line for long intervals. Spacetime itself adds Lady's handwriting on top, apsidal advance from curvature, nodal drift from spin, tiny extra twists from the quadrupole moment if the central spinner is not a perfect sphere of gravity. Track those twists carefully enough and you are testing that no-hair statement with a planet as your pen. Material properties decide microscale outcomes that telescopes can, in principle, see. A silicate globe with a thin atmosphere radiates heat in sharp pulses and shows strong orbital harmonics. An ice-rich body wears a deeper thermal memory and peaks later and longer. A mini-Neptune with a puffed hydrogen shell shows broad, muted crests with photochemical afterglows that last into the cold months. Magnetic moments matter. A strong dynamo breeds radio bursts and fierce auroras. A dead core leaves only the sputtered exosphere and dust. Rings survive if self-gravity and collisional damping can beat differential precession. If not, they dissolve into transient spirals that recur each hot season. Moons persist if their Hill spheres stay intact at pericenter. If the line tightens too far, satellites are peeled away into their own brief, beautiful lives as inner debris. The violence of closest approach also forges minerals that elsewhere need deep crustal ovens or large impacts. Shock veins freeze into masculinite-like glasses, high-pressure ices build and unbuild, iron sulfides rearrange, nitrides and cyanides condense in the upper air and snow out as brittle films that crackle electrically under auroral rain. Meteoroid environments spike because the inner precinct is dusty and many bodies share similar paths. Impacts prefer the weaks near pericenter, so craters cluster in longitude and carry vitrified splashes that betray the direction of the plunge. One can imagine reading, centuries later, a run of closely spaced microcraters on a rover's hull and inferring the exact argument of pericenter that year. Some refugees find a loophole. Mean motion resonances with other small bodies near apicenter can freeze the pericenter distance at a safe value even while the rest of the ellipse precesses. Those resonant shepherds form ghost families, swarms that share a preferred closest approach and, viewed edge-on, draw repeated arcs in scattered light inside the central glow. Others are guided by gas. Weak, steady drag can herd populations into narrow corridors of phase space, the way snow fences cause dunes. In a richly fed nucleus, these soft forces can outweigh random kicks, creating long-lived belts of invisible worlds that announce themselves only by their synchronized heating. Push the parameters to their limit and stranger scenes appear. A super-Earth returns again and again to a pericenter a few dozen solar radii from a spinning colossus. Relativistic beaming of the central halo makes the sky brighten anisotropically during each dive, and the horizon's photon ring smears into a bright, offset hoop that slides across the planet's night side like a slow searchlight. The globe's deep mantle stays partially molten for geological ages. A carbon-rich atmosphere builds photochemical suits that collapse into brief, oily rains. Ocean under-ice worlds vent towers of vapor at the hot season and lay down thick hoarfrost at aphelion, a respiration visible in the infrared from 500,000 light-years away. None of this requires a daytime or a lamp, only a deep well in time. From afar, this starry republic's core looks calm, a soft glow, a few brilliant flares, a ballet of fast stars. Under that calm is a census of hidden citizens, worlds that chose gravity over daylight and learned to live by a different clock. They carry seismograms of curvature in their crusts, auroral scars in their skies, chemistry written by radiation instead of sunshine, and histories punctuated by tides rather than seasons. Call the host what you like, the spiral realm, the island of suns, the luminous federation. The rule at its heart is simple and absolute: fall toward the deepest place, learn its rhythm, and if you can, make a life there. Say the word and we can chase one traveler through a full year of its impossible orbit, from the far dark to the furnace and back, reading in every glow and crack how a planet becomes a chronometer for a gravity well. Take one full circuit and stretch it into a diary. Far out in the cold quarter of its path, the night-bound globe drifts through the quiet suburbs of the stellar polis, where the crowd noise of the central district is only a rumor. The sky is a powdered salt of distant lamps, the great dark turbine is just a smudge of high-energy frost, brighter to instruments than to eyes. Here the planet breathes slowly. Convection cells in the mantle climb and fall without hurry, tidal stress is a background hum, and any ocean beneath ice turns over on month-long loops, not minutes. The atmosphere, if one exists, reaches chemical standstill, radicals quenched, haze is settled, trace gases partitioned between air and brine. Animals, if any, evolve to match gradients rather than daylight, idle and store energy like desert seeds after a rare rain. Approach begins as a whisper in the crust. Tidal harmonics strengthen, first as a soft beat riding the planet's rotation, then as a clear rhythm that tides can lock to. Faults unglue at predictable longitudes, cryovolcanic throats pressurize, ring particles march into spiral density waves that a low orbiter could count like grooves on vinyl. The sky brightens in a way that no childhood teaches, not from a rising lamp, but from a whole quadrant growing milkier as the inner halo of the central dynamo swells with Doppler-boosted light. Magnetic drapery thickens around the planet's moving obstacle, the bow shock intensifies and the magnetotail lengthens, beating with reconnection sites that pop like underwater welding. Midway through the plunge, induction turns the world into a generator. Motion across the core's tangled field drives currents that close through the ionosphere and the interior, Joule heating adds to the budget, auroral ovals widen and split. The spectrum hardens. X-rays punch chemistry into pieces, ultraviolet scribbles nitrates into the high air, and charged particles dive down field lines to seed odd nitrogen and peroxides that will sink into oceans weeks later as slow oxidant rain. If the cloaked traveler is a sub-Neptune, the puffed hydrogen mantle cools and expands at altitude even as deeper layers warm. If it is rocky, the daytime that never comes is replaced by thermal bruises, hotspots set by stress rather than sunshine, that drift under jet streams like continents of fever. Closest approach arrives as geometry, not sunrise. The horizon wears an offset ring where photon paths graze the rim of the abyss. The ring slides across the night side like a slow, luminous hula hoop, brightening and dimming with relativistic beaming as the inner flow rotates. Gravity is now a sculptor you can feel in your bones. Mountains shrink elastically by millimeters and rebound, deep rock nears its yield. In ductile layers, strain localizes into shear zones that light up with microscopic melts. In brittle caps, aftershocks ripple in trains. An ocean sealed under ice goes tidal like an organ pipe, pressure waves ring, frazzle crystals churn, and brine plumes bloom into temporary chimneys that exhale warmth and trace gases. If the globe wears rings, ram pressure kinks their rims and nodal precession tilts them a few degrees. If it carries a moon, the satellite's hill sphere pinches, and the little companion loses dust to a faint arc that will be sheared into a filament before the next far winter. Pericenter is also a laboratory for relativity. The track is not a closed ellipse but a petaled rosette. After each dive the argument of pericenter jumps forward, so the next furnace week arrives at a different longitude. If the central spinner's axis is tilted, the orbital plane nods, and the ring's shadow at pericenter swings year to year like a sundial that reads spacetime. Those tiny geometric shifts are clocks. Fold the mid-infrared light curve on the nominal period and watch the peak creep, map polarization spikes from forward scattered dust and see them march relative to the thermal crest, time radio bursts from induction and measure the beat as the plane precesses. Put those beats together and you weigh the central anchor, gauge its spin, and sketch its quadrupole, the way a bright S-star does, but with a cold, small, stubborn pen. After the whip, recovery. The plasma thins, radiation softens, the bow shock retreats, aurora dim to ghostly caps. Chemistry keeps momentum, nitrates rain out, peroxides and knocks burrow into brines, polymer haze snow settles like a dirty hoarfrost that later sublimates from the subpolar basins. Thermal inertia writes fat tails into the light curve, a rocky globe's emission drops fast, an ice-rich world lingers, a mini-Neptune smears the peak into a broad shoulder with photochemical afterglow. On the ground, or under it, ecosystems, if they exist, pivot from repair to metabolism, spending the oxidants banked during storm week. Tidal heating falls back to background, but not to zero. The interior remains warmer than any starless night would allow, and over geological spans the cumulative budget rivals small moons in ordinary planetary systems. Zoom out to the host to see why these stories differ across neighborhoods. In a barred stellar province, gas lanes feed the hub and thicken the medium. Aerodynamic capture favors pebble-to-comet scales and shepherds small worlds into families with a shared pericenter direction, ghost belts that paint repeated arcs of faint dust inside the central glow. In a giant ellipticals downtown, the central engine is heavier and the safe corridor for rock is wider. Captured super-Earths can skim close, survive, and become periodic heat lamps that season the inner fog with solids. In dwarfish capitals with lightweights at the core, rock must dive too near for comfort, ribbon-making events dominate, and the inner precinct wears transient, shock-bright rings that wink on and fade as streams intersect. The same dynamical census that sets how often bright flares occur also sets how many hidden citizens ride rosettes instead of going to ribbons. Instrumentation chooses its battles. Mid-infrared timing favors the cadence of heat, sub-millimeter ears listen for cyclotron maser bursts from induction, optical polarimetry hunts the small, highly polarized flashes from forward-scattered dust arcs. High-resolution spectroscopy targets alkali lines, sodium, potassium, broadened by pressure and seasoned by sputtering, while neutral oxygen and carbon glow in forbidden lines that tell how much exosphere is being gnawed away. Precision astrometry in the inner parsec catches tiny, correlated tugs on nearby tracers. Even if no single world stands out, a population adds texture to the dance that a patient interferometer can untangle. Future low-frequency space antennas might someday hear the soft gravitational murmurs of the tightest, most massive survivors, a planet-scale extreme mass ratio whisper mapping the deepest contours of the central well. Material strength, not just mass, decides the microphysics that telescopes can read. Silicate skins radiate sharply and crack loudly, ice mantles store heat and exhale slowly, hydrogen cloaks mute peaks and lengthen tails. Strong dynamos blare in radio and paint brutal aurora, dead cores go quiet except for sputterglow and dust. Rings persist if self-gravity and collisional damping beat differential precession, otherwise they dissolve and reform on each hot season, leaving a repeatable barcode of tilted spirals. Moons last if their spheres of influence survive the pinch at closest approach, otherwise they peel off into temporary arcs and then into nothing, contributing a faint, periodic drizzle of grains to the inner haze. Even failure leaves knowledge. A shredded world becomes a thin, phase-wrapped stream, where the loop self-intersects, shocks light the gas and sculpt a broken ring whose precession rate encodes the mass and spin of the core. Charged grains from the stream drift under Lorentz forces into polar brushes. If those cross the line of sight to a bright background tracer, the light curve fractures into a set of knife-edged dips that step with the ring's thickness and twist with its knotting. Read those dip trains long enough, and you reconstruct the geometry of a place that cannot be visited, only inferred. What looks from far away like a calm ember in the middle of the star archipelago, one soft glow, a few flares, a fast ballet of test stars, is in fact a city center with weather. Hidden among its traffic are worlds without dawns that keep time by curvature, store heat from tides, and write their calendars in layers of glass, salt, and ice. They exchange daylight for deep well discipline and find ways to live by it, by chemistry that resets instead of cycles, by oceans that breathe to a relativistic beat, by rocks that remember the angles between gravity's petals. Call the host what you wish, the spiral dominion, the luminous burrow, the island of suns, the stellar commonwealth. Its law is simple and welcoming to any drifter: if you can fall and not unmake yourself, you can belong. Modelers sketch the corridors where survival beats shredding by writing down the simplest balance they can and then adding the necessary sins. The tidal radius scales as the planet's size times the cube root of the mass ratio. Set that against the closest approach and you get a pass/fail strip in phase space that widens for ices and narrows for iron. Layer on viscoelastic dissipation and that maybe region fattens, because worlds that flex and heat also bleed orbital energy and lift their pericenters over thousands of loops. Around a modest central colossus, millions of suns, the safe lane for rock sits outside a fraction of an astronomical unit. Scale the engine up by 1,000 and the same world can skate far closer because the gradient softens. That counterintuitive truth means giant ellipticals in the constellation capital may keep more intact wanderers, while tinier cores in drowsier townships make ribbons as a rule. Rates matter, and the Star Republic's downtown is generous. Nuclear clusters seed three-body captures whenever a star-planet pair grazes the central well. Roughly one in many thousands of plunges will park the smaller companion on a needle ellipse while the lamp is flung outward, dazed but bound to the greater burrow. Rogue supply is not an issue. Galactic disks eject planets by the billions over cosmic time through migration mishaps and dynamical brawls. The central precinct, with its thick crowd and drifting gas, sweeps a share of those drifters into membership. Add weak aerodynamic drag from hot plasma and a slow rain of tiny energy losses at each dive, and a fraction of passers-by trade visitor badges for residency. The metropolitan sum is not a handful of exotica but a shadow population, countless cold citizens tracing rosettes that no ordinary eclipse will ever reveal. Observation strategies read like scavenger hunts. In the spiral confederation closest to home, the inner parsec is already mapped in moving dots, amplified at precision, and a planet mass tug becomes visible as correlated wiggles in the paths of faint tracers. In the nebular city-state farther away, timing wins, mid-infrared light curves that crest on schedule and creep in phase with relativistic advance, sub-millimeter spikes from induction-driven aurora that sharpen near pericenter, polarized flashes from forward-scattered dust arcs that precede the heat peak by a predictable offset if rings tilt under frame dragging. High-resolution spectra taken during the hot week look for broad alkali lines from a puffed exosphere and faint forbidden oxygen that tells how much atmosphere was gnawed away. Stack multiple orbits and the geometry falls out, mass from the period and amplitude, spin from the nodding of the plane, quadrupole from the rate at which the petals open. Climates on these nightbound worlds learn to budget like miserly accountants. Hydrogen-rich mantles build deep, warm tropospheres by collision-induced absorption. Tides inject heat spikes that circulation smears horizontally, while vertical mixing ferries oxidants from auroral caps down to dark oceans. On rocky bodies, partial melts rise and stall as sills, glassing over between passages and preserving a palimpsest of furnace weeks. On ice giants, ammonia, water brines maintain conduits that open during pericenter and pinch shut in the far winter, a respiration that leaves textural bands readable by any lander that ever learns to break in such a sky. Chemistry never settles. Radicals made aloft during the storm week diffuse for months and finish their reactions in places sunlight never finds, so redox cycles are written by orbit phase, not diurnal pattern. If life appears, it would likely hoard enzymes that pre-activate repair pathways before the plunge and hibernate in the long coast, treating gravity as weather and spacetime as calendar. Magnetism carves signatures loud enough for distant ears. Motion across the central field drives alphane wings that link the world to the glow. The unipolar inductor model predicts radio bursts whose frequencies trace the local gyro frequency and whose power scales with the square of the relative speed. Those bursts should cluster near true anomaly windows where the planet slices across strongly magnetized streams and where reconnection tears the tail. The induced currents heat the ionosphere, coupling into neutral winds that, in turn, shift where auroral chemistry writes its nitrates and peroxides. A strong native dynamo multiplies the effect, caging charged particles and staging auroral crowns so bright that even the muted night side would flicker in false dawns. A dead core does not go silent, it sputters, but its radio is thin, its aurora ghostly, its chemistry slower. Rings and moons become reporters almost against their will. Ram pressure hums at pericenter, kinking ring rims and launching spiral density waves whose wavelengths encode the local gravity and the drag the particles feel. Differential precession twists those patterns into barcodes that, read over successive passes, reveal how the orbital plane nods and how the petals of the rosette open. Satellites survive only if their Hill spheres stay generous at closest approach. In border cases, a moon is peeled into a debris arc that flashes in forward scatter and then is ground into a filament. The timing of that flash relative to the thermal crest pegs how close the peel happened. Rarely, a resonant partner at apicenter can hold the pericenter distance steady despite all the other torques, ghost shepherds that keep a family of worlds alive by freezing the dangerous angle where tides would otherwise squeeze too hard. Shredding is not a coda but a chapter. Cross the narrow line and the traveler lengthens into a stream, inner segments rush ahead, outer ones lag, and when the loop closes the self-intersection shocks light the gas and slap the dust into a broken hoop that precesses. Charged grains in that hoop drift along field lines, painting polar brushes. If a bright background tracer schemes behind, the light curve suffers a stack of razor-edged dips spaced by the ring's thickness and shifted by nodding. That signature is a decoder for the mass and spin of the central engine and a postmortem for the world that failed the corridor by a cruel percent. Everything scales, so the constellation Commonwealth writes variations on the theme. In a metropolis where the core is heavy and fed, the photon bath at 1 astronomical unit during flares rivals noonday on ordinary worlds. Volatile skins boil, haze factories roar, and dust wakes are certain. In a quieter burrow with a leaner engine, radiation sculpts chemistry without much heat. Atmospheres thicken with polymers and nitriles that snow in the months after pericenter and sublimate again next year, painting a seasonal loop with no sun involved. In barred provinces, gas lanes favor drag capture and then herd survivors into belts with shared pericenter directions. In dwarf townships, the safe corridor is so narrow that the inner haze is continually refreshed by fresh ribbons and the dust arcs are young and bright. If intelligence ever rides one of these rosettes, its engineering would look nothing like the lamp worship of ordinary civilizations. Energy arrives in predictable surges from tides and induction. Heat sinks are the great dark. Line-of-sight backlights are everywhere thanks to the lensing hoop. Power grids would learn to drink the hot week and sleep the far winter. Chemistry labs would time their radicals to the auroral rain. Observatories would treat the photon ring as a calibration lamp sliding across the sky. Technosignatures would pulse with the orbit, waste heat that crests near pericenter but lingers longer than geology alone would allow, coherent radio that rides the induction bands, artificial haze clearing patterns that oppose photochemical production. Even without such contrivances, the natural cadence is generous enough to find with patient instruments and an appetite for the subtle. From the high balcony where we name things, the luminous federation is just another galaxy, a smear with a bright heart. From the level where orbits scrape physics raw, it is a workshop for worlds that swap daylight for a deeper rule. They keep ephemerides in glass veins and salt layers, promise their storms by geometry instead of sunrise, and add their quiet, periodic breath to the glow that marks the center of the starry union. Call that host a spiral precinct, a stellar dominion, a city of lamps, names or costumes. The law underneath is always the same. If a wanderer can surrender just enough energy without surrendering itself, the core will make a citizen of it, and the rosette will do the rest. Spin is the quiet conspirator that decides how a captured traveler ages. Tidal torques try to lock rotation to a resonance with the orbit. The target is not a friendly 1:1 like ordinary moons but a shifting compromise because the planet spends almost all its time creeping and a few days sprinting. Many worlds settle into chaotic tumbling with preferred states near 3:2 or 5:2 between spin and mean motion, then hop when the pericenter precession drifts the forcing frequency. Obliquity is not a noble constant either. Close approaches yank the spin axis, and any liquid core or subsurface ocean acts like a gimbal that lags behind the torque, turning each dive into a small, cumulative tilt. Over thousands of loops the interior picks a rheology to live by, Maxwell-like if warm and wet, Andrade-like if crystal lattices dominate, and that choice sets how efficiently orbital energy becomes heat. A rubbery ice shell with a relaxation time of hours answers the tide like a drum, a glassy mantle with a relaxation time of years takes the punch late, smearing heating into the coasting months and rewriting the thermal light curve. Escape is a ledger with two columns, thermal and non-thermal, and pericenter pays both. In the hot week, X-ray and ultraviolet photons pump the thermosphere until the exobase swells. If the binding energy per particle is low enough, a hydrodynamic wind lifts off and mass loss goes energy limited, proportional to the incident high-energy flux and the cube of planetary radius divided by the mass. Where photons cannot finish the job, particles do. Charge exchange and sputtering knock heavy atoms free, and pickup ions carry them down the magnetized flow. Hydrogen cloaks survive by sheer inventory, rocky air survives by molecular weight and by hiding in cold traps between dives. Mini-Neptunes walk a line where a few 100 million years of furnace seasons can peel their outer envelopes and leave warm super-Earths with photochemical scars. Every lost kilogram is a page torn from the future chemistry set, and yet those very losses write signals in sodium and potassium lines, in far ultraviolet oxygen glow, and in radio whispers from pickup currents that a patient telescope can count. Surface processes answer on their own clocks. On rock, tidal quakes stitch dense networks of microfaults that creep at aphelion and unlock at the plunge. Veins of high-pressure minerals freeze in milliseconds, glassing in tracers of stress direction like arrows on a map. On ice, brine channels anneal into fabrics that remember the last dozen hot weeks. As convection strengthens, diapirs of warm, salty ice rise, stall, and leave pitted plains where they breached, features that would be mistaken for cryovolcanic calderas anywhere else. If a carbonaceous crust lies shallow, ultraviolet at pericenter cooks polyaromatic residues that darken the surface and steepen thermal contrasts. When the planet coasts back into darkness, those contrasts drive katabatic winds under a starless sky, lofting dust that seeds the next season's hazes. A world with even a modest biosphere would treat these pulses as festival and famine. Enzymes timed to the electrical season would pre-arm repair pathways, membranes would stiffen against peroxides, and metabolic networks would bloom when oxidants rain out and sleep when the pantry runs low. The central engine's demeanor matters, and hubs across the Starlight Republic offer a spectrum of moods. In a well-fed downtown, the inner flow is thick, the photon bath is bright, and the magnetic topology changes on human timescales. Captured citizens see furnace weeks that rival noons on ordinary worlds and induction storms that light polar skies like continents. In a leaner precinct, the glow is hard but faint, chemistry is carved more than cooked, and atmospheres evolve toward heavy, stubborn mixes that weather the years by polymerizing aloft and raining thin films that crackle under weak aurora. In barred provinces, gas lanes see gentle drag that rounds orbits and herd survivors into belts with shared closest approach longitudes. In dwarf cantons with lightweight cores, survival lanes narrow until stone must flirt so close to the rim that ribbons outnumber rosettes and the inner haze is young and constantly replenished. Crowds breed resonances, and even worlds that never meet change one another. Near apicenter, mean motion commensurabilities trap pairs into exchanging angular momentum on slow beats that keep their pericenters from wandering into danger, a mutual aid society of invisible citizens. Farther in, secular resonances tied to the precession rate of the whole cluster can pump inclinations while damping eccentricities, trading plunge risk for tilted loops that paint the inner glow with high-latitude dust. Occasionally a compact remnant on a plunging track kicks the dice. A brief, strong encounter flips a survivor's orbital plane or nudges eccentricity over the safe line, and a future hot week becomes the last. If a moon or ring was along for the ride, its fate becomes a timestamp, where in the orbit the peel happened, how thick the arc became, which way the spirals were twisted by nodding, clues preserved in polarized flashes that arrive like punctuation before the thermal crest. Detection strategies reward stubborn watchers. Mid-infrared timing remains the anchor, because heat tells the truth, peaks that recur on schedule but creep in phase as the pedaled path advances, widths that diagnose heat capacity, tails that separate ice from rock from gas. Low-frequency radio, if caught, gives sharp hooks to hang models on, auroral bursts that map gyrofrequencies and therefore field strengths in the flow, reconnection crackles that clock the magnetotail's geometry, quiet intervals that reveal when the planet is gliding along field lines instead of cutting across them. Optical and near-infrared polarimetry hunts for small, highly polarized flashes from forward-scattered dust and transient rings. Spectroscopy during the hot week chases broadened alkali lines and faint oxygen-forbidden lines, while submillimeter ears listen for continuum bumps from warm dust wakes. Stack a handful of orbits, fold by the changing period, and the central mass drops out. Track the nodding of polarization peaks relative to thermal crests, and spin follows. Measure the rate at which the peak time drifts, and the quadrupole peaks through, a test of whether the dark turbine's gravity is as bald as the no-hair dictum insists. Engineering thought experiments sharpen the picture. A civilization riding such a path would build grids that charge on tides and induction, not sunshine. Heat sinks would be the deep night. Observatories would use the photon ring as a moving calibrator sweeping the horizon each furnace week. If they farmed chemistry, they would time reactors to the oxidant rain and pipe brines through porous rock when tides are high. If they signaled, their waste heat would crest too symmetrically unless they intervened. Their radio would ride the induction bands where nature also shouts. Their haze would clear with a phase that fights photochemical production. None of that is necessary to make the case, but it means technosignatures here would be periodic, geometry-locked, and layered atop a cadence written by gravity itself. The most fragile chapters leave the crispest tracers. When a traveler misjudges the corridor and lengthens into a stream, the broken ring that follows precesses like a slow metronome. Each time it crosses itself, shocks brighten and the inner fog glows in arcs. Charged grains drift into polar plumes aligned with the big field. If those brushes pass in front of a bright background tracer, the light curve steps down and up with knife edges that repeat with the ring's thickness and nod with the plane's drift. Read a few seasons of those steps and you can reconstruct the ring's tilt, the precession rate, and therefore the central spin, an autopsy that doubles as a map of the deepest gravitational contours in town. All of this turns the luminous Dominion's core from a decorative spark into a laboratory where worlds trade daylight for a stricter rhythm. The captured citizens keep clocks in glass veins and salt bands, write calendars in auroral nitrates and polymer frosts, and evolve climates that answer to pericenter rather than noon. They make the inner haze thicker or thinner, they see dust arcs that whisper in polarization, they flex into heat that leaks back out as infrared that anyone with patience can time. Call the host a stellar municipality, a radiant conurbation, a republic of lamps, a city of suns. The name is a label on a law that does not change. Fall toward the deepest well you can find, spend energy to survive the closest pass, store the memory in stone and ice, and come around again on schedule until a kick ends the story or the orbit rounds into a quieter life. Over time the electricity of motion writes architecture across the traveler's skies. Alphane wings tether the globe to the inner glow like invisible guy wires, where those current systems close through the ionosphere. Narrow jets of neutral wind spin up and carve long-lived channels in the upper air. Those lanes become the preferred highways for photochemical products after each furnace week, so nitriles and peroxides migrate along repeating great circles that a spectrograph could map as season-locked ribbons. If the world's dynamo is strong, induction pushes it toward a quasi-steady state in which the ionospheric Peterson conductance increases during the plunge, raising the Joule heating fraction and shifting the thermal crest slightly earlier than tides alone would predict. That phase lead is small but diagnostic, a few degrees in true anomaly that separate an ice mantle from a rock mantle, a dead core from a living one. Spin evolution never stops negotiating. YRP-like torques appear even without a sun because the radiation field near pericenter is anisotropic and the surface emits heat with strong longitudinal contrast. The net recoil from that uneven thermal glow nudges rotation rates over many loops. Add a lopsided ring or a triaxial shape and the planet's tumbling becomes a slow walk across resonances, with brief windows of apparent stability followed by chaotic flips when the pericenter advances into an unlucky geometry. Obliquity tides couple to this dance, pumping energy most efficiently when the spin axis hovers near certain tilts. Worlds can self-tune into these hot tilts and then drift away again as the rosette opens petal by petal. Rings tell their own patient story. Pointing, Robertson drag and plasma drag both act at pericenter, shortening particle semi-major axes in bursts. Between dives, collisional cooling and self-gravity shepherd the debris back toward narrow bands. Differential precession under the central quadrupole twists those bands into repeating spiral barcodes. Frame dragging adds a slow nod that lifts and lowers the pattern against the planet's equator. Read that barcode over a handful of orbits and the central spin sign, prograde or retrograde, drops out, along with a crude measure of its magnitude. If a small shepherd moon survives, its wake carves scallops whose spacing fixes the moon's mass. If the moon is peeled during a particularly hard season, the sudden loss imprints a sharp change in the ring's optical depth that becomes a timestamp for the corridor's narrowing. Geophysics turns the orbit into mineralogy. At pressures found a few hundred kilometers down, silicates cross phase boundaries that sequester water and carbon differently. Pericenter pulses can drive short-lived dehydration or decarbonation fronts that move upward as waves. Those fronts leave glassy, volatile pore veins frozen on minute timescales, an igneous Morse code that records not weather but geometry. In ice, clathrates form and fail on the march. Methane clathrate cages build between dives and collapse when pressure drops in tidally pumped fractures, venting plumes that paint nearby snow with dark organics before the cold winter seals the holes. The cumulative effect is a crust that looks like it endured alternating impact epochs and volcanism, except the spacings are clockwork and the provenance is gravity, not randomness. The radiant municipality that hosts this all furnishes backlights for free. The photon ring is a moving calibration lamp. Background stars in the inner arcsecond of the hub are plentiful. Filaments of ionized gas thread the district like neon signs. A transient dust wake from the traveler, viewed against any of those backgrounds, polarizes light by forward scatter. Polarization degree and angle peak slightly before the thermal crest, and the offset grows if the orbital plane nods from the core's spin. In an observatory's ledger, that means thermal phase curves in the mid-infrared to anchor the heat, polarimetry in the red and near-infrared to time the dust flashes, sub-millimeter monitoring for induction-driven cyclotron masers, and high-dispersion spectra around the sodium and potassium doublets to catch puffed exospheres broadened by pressure and stirred by sputtering. Stack a few orbits, fold by the creeping period, and the mass, spin, and quadrupole of the central citadel arrive without a single eclipse. Population thinking turns anecdotes into a census. Disks fling out wanderers by the billions. Nuclear clusters in star archipelagos run three-body exchanges as a matter of course. Gas lanes in barred provinces thicken the medium and make aerodynamic capture plausible for anything from gravel to icy dwarfs. The capture cross-section for planet-star pairs grazing a central engine scales with the density of binaries and the velocity dispersion of the downtown, both rise toward the core. Even if only a sliver of encounters end in residency, the steady supply over gigayears implies a shadow population, cold citizens on eccentric rosettes, a minority shredded into ribbons, a smaller minority circularized into warm, dim embers that seed the inner fog with dust. Their integrated effect may already be in our data as excess, phase-coherent variability and faint, repeating arcs inside the central glow that no supernova remnant quite explains. Habitability, stripped of daylight, becomes a question of budgets, shields, and timing. A hydrogen ocean under a heavy sky can sit at room temperatures at depth even in the long coast, with convection closing the loop between the oxidants laid down by aurora and the reductants percolating from hydrothermal systems pumped by tides. Life that evolves in such a place would not use diurnal cycles, it would train to the furnace week, pre-arming DNA repair, switching membrane chemistry, and hoarding or dumping antioxidants on schedule. Biosignatures, if they ever escape, would be orbital. Trace gases that spike in a predictable phase window, spectral albedo changes from transient films laid down after pericenter, maybe even faint, periodic radio quieting if a biosphere learns to ride the induction weather rather than fight it. None of that is necessary for the physics to sing, it is simply what chemistry and time allow when geometry runs the clock. Push the parameters and the constellated republic answers with extremes. Around a truly massive central sovereign, the tidal radius for rock ducking inside the photon ring is still outside the horizon, so an iron-heavy super-Earth can skim perilously close and live. Relativity then dominates the narrative, smearing the sky with beamed light and nudging the thermal crest forward with each pass. Around a lightweight core in a dwarf canton, the safe corridor shrinks until pericenter heating and ram pressure cross into demolition, so ribbons are common and broken rings press S like slow metronomes that modulate the inner haze. In gas-rich capitals, drag capture rights families with shared closest approach longitudes. In austere districts the survivors are those that lucked into long-lived resonances that freeze a safe pericenter while everything else precesses. From a great remove, the island of suns is still just a soft flame in a dark room. Up close, its downtown is busy with hidden citizens who learn to keep time by curvature. They carry auroral scars instead of sunsets, store heat in tides instead of summer, and write their history in glassy veins, salty bands, polarized flashes, and infrared breaths that recur on schedule. They turn a galactic hub, this spiral ward, this luminous arrondissement, this stellar capital, into a metronome. And the rule that admits them is spare and merciless and strangely generous. Give up the right amount of energy in the right place, pass the corridor without unthreading, and you may trade daylight for membership, returning again and again along a pedaled path that only gravity could draw. The sky above such a traveler is never the same twice, and the differences are not weather so much as geometry. As velocity climbs, aberration drags the whole firmament forward, background stars crowd into a bright wedge, their spectra Doppler shifted blue while the opposite sky thins and reddens. Lensing adds a second trick, as the globe sweeps through changing impact parameters, caustic scrawl faint, moving arcs across the heavens, brief mirages of remote suns folded by curvature. Near the razor-close segment, the photon ring of the central citadel brightens into an offset hoop, its brightness modulates with the spin of the inner flow, and its position creeps from year to year as the rosette opens. With a small telescope and patience, inhabitants, if any, could treat that hoop like a drifting metronome, calibrating clocks and long baseline interferometers by a light that is not a lamp but a path. Beneath that shifting dome, heat does not come from a hemisphere but from a harmonic degree. Two tides paint twin warm lobes that chase the subpericenter longitude. Viscosity decides whether the crest leads or lags the stress. In a soft ice shell the peak arrives early and smears into a broad belt. In glacier rock it arrives late and tall, a thermal bruise that slides under jet streams. The circulation it drives is alien to sunlight worlds, superrotation born from longitudinal pressure contrasts, gravity waves that break where tides focus, and atmospheric tides that resonate with the body tide to amplify or mute heating by small phase shifts. Couple that to a magnetic crown and the result is a three-layer energy ledger, joule heating aloft, tidal dissipation below, and advective work in between, that writes telltale offsets into the mid-infrared phase curve. Chemistry answers in isotopes as much as in molecules. Each furnace week peels the lightest atoms first, hydrogen and nitrogen escape with fractionation that enriches deuterium and heavy isotopologues over many seasons. Sodium and potassium, sputtered from surface and cloud tops, broaden into fat lines with non-Maxwellian wings because pickup ions sample velocity space unevenly. Nitriles polymerize into Tholin hazes that collapse as brown frosts when the world coasts back into dark. Peroxides and odd nitrogen rain into brines, where they oxidize sulfides and drive serpentinization that vents hydrogen back up, a closed, gravity-timed redox loop. If biology ever joins the conversation, it will inherit those clocks and chemistries, enzymes pre-arm for radiation bursts, membranes swap unsaturations to ride peroxide tides, and metabolisms hoard oxidants laid down at auroral caps, then spend them in the slow, dark months below. Deep inside, mineral physics conducts the score. As pressure and temperature sweep across phase boundaries on a monthly cadence, olivine flips polymorphs, clinopyroxenes exsolve, and water migrates between lattice sites and melt. Short, hard pulses near closest approach drive dehydration fronts upward. During the coast, rehydration creeps downward along grain boundaries. The alternation welds glassy veins that freeze in minutes, arrows pointing toward the instantaneous tidal axis. In ice, clathrates build in pores during the long winter, then collapse when pressure drops in fractures at the plunge, venting bouquets of methane crystals that sift downwind like volcanic lapilli. Even a dead world becomes a diarist. Microseisms at the body's normal modes ring on every pass, and their slow drift in frequency as the orbit fattens or thins is a seismogram of orbital evolution. Rings and rubble add their own punctuation. Pointing Robertson drag is not sun-driven here but furnace-driven. The anisotropic radiation bath at Perry Center does the work, nibbling semi-major axes in bursts. Plasma drag contributes an impulse as the ring punches the bow shock. Between drives, self-gravity wakes and inelastic collisions cool the debris into narrow lanes, only for differential precession to twist them into spiral barcodes whose spacing records the local gravity gradient and the central quadrupole. A shepherd moon that clung on will sculpt scallops. If that moon is peeled during a hard season, optical depth steps down abruptly and stays low, a timestamp in geometry. Crowds make corridors. Near epicenter, mean motion resonances between otherwise invisible citizens can lock pericenter distances, freezing the dangerous angle while the plane nods. Secular resonances tied to the larger cluster trade eccentricity for inclination, sending some survivors onto high-latitude loops that seed the inner glow with polar dust. Occasionally a compact remnant dives through, a neutron star on an eccentric chute, a small black hole on a plunging pass, and flicks a traveler's ellipse over the red line. The aftermath is bright and diagnostic. A thin streamer phase wraps, self-intersects, and builds a broken hoop whose precession rate is a clean measure of the central spin. Charged grains drift into polar brushes that, when they skate across a backlit filament, carve knife-edged dips in a light curve that step with ring thickness and nod with frame dragging. From far outside the lamp city, the signs are subtle but stackable. Mid-infrared light curves that crest on schedule but creep in phase as pericenter advances, sub-millimeter bursts that cluster at predictable true anomalies where induction bites hardest, polarized flashes that arrive just before the heat peak when forward-scattered dust rings the globe, alkali lines broadened by pressure and spiced by sputtering during the hot week. Precision astrometry in the inner arcsecond of the galactic capital adds a statistical lever. Even if no single planet's tug is obvious, a population corrugates the orbits of faint tracers in a way that an interferometer with a long memory can peel out. In gravitational waves, only the tightest, heftiest survivors will murmur in millihertz bands, planet-scale extreme mass ratio whispers, but if the luminous arrondissement is generous, there will be more than one, and their chorused phasing will chart the deepest metric where photons and dust cannot go. The long fate of a captured sphere is a slow bargain with dissipation. Tides inside the world fatten the ellipse and lift pericenter. Weak hydrodynamic drag near the inner flow steals specific angular momentum. Resonant kicks from neighbors add stochasticity. Many paths round toward warm, dim embers threading inside the inner haze, where the globe sheds fine solids that catalyze molecule making in the glow. A minority ratchet upward in eccentricity until the corridor narrows to nothing and the world becomes ribbon, ring, and finally fog. Scale the central sovereign up and the safe lane for rock actually widens, the gradient softens, so an iron-heavy super-Earth can skim outside the photon ring and live. Scale down to a dwarf canton and survival demands almost impossible aim, so streams and newborn hoops become the norm. Spin and tilt never truly settle. Anisotropic re-radiation near pericenter, no sun required, acts like a YORP engine, whispering torque into uneven terrains and lopsided rings, chaotic tumbling toggles among resonant islands, 3:2 for a few centuries, 5:2 for a few more, then a sudden flip when the pedal angle lands wrong. Obliquity tides sip energy best at special tilts, and interiors with oceans or liquid cores lag the torque, ratcheting axis angles by fractions of a degree per thousand orbits. All of that is visible in principle because it changes the phasing of heat, the width of the crest, and the polarization angle of dust flashes. A map of those drifts over a handful of years is a poor man's interior probe, ice versus rock versus gas, dead core versus living dynamo, read across parsecs. Even the background turns into a tool. Pulsars grazing the inner burrow throw steady radio ticks. When the traveler swings between us and one of those clocks, the path length shifts by tens of microseconds from Shapiro delay in the central well and by nanoseconds more from the planet's own gravity, modulated at the orbital phase. Stack enough passes, and you isolate the small, periodic signature of a world that never transits anything and reflects almost no sunlight at all. If a bright filament snakes behind the globe at pericenter, microlensing by the planet briefly spikes the filament's brightness with a two-peaked, asymmetric blip whose separation encodes the Einstein radius and therefore the mass. Detect two such blips a year apart, creeping earlier by the apsidal advance, and you've weighed a nightbound object with geometry alone. Push imagination toward engineering and the constraints sharpen rather than blur. Power comes in tides and induction. Heat sinks are inexhaustible night. Communication loves the low-frequency bands where auroral physics already shouts. Infrastructure would cluster along stress shadows that go cool between furnace weeks, drilling would follow seismic nodes that ring strongest at each pass, agriculture, if chemistry earns the name, would be brine-based, redox-timed, and shielded under meters of ice or rock. Waste heat would crest too symmetrically unless managed. Haze clearing would fight photochemical production on a schedule written by orbit. Radio beacons would either avoid or lean into gyrofrequencies where the sky is loudest. Even without artifices, the natural cadence, thermal, polarimetric, spectroscopic, astrometric, gives us all the hooks we need. From a distant ridge where we label whole structures, the spiral dominion is a soft ember with a bright kernel. Drop to the level where a single captured sphere keeps time, and that kernel is a machine for writing memory into matter. Planets without dawns become clocks, rings turn into barcodes, dust wakes into polarizers, veins of glass into arrows that point toward pericenter long after the orbit has changed. The rule of the radiant municipality is austere but enabling. Part with the right energy in the right place, thread the corridor, and the city of suns will grant you a path that repeats. On each return you will be shaved by fields, cooked by photons, kneaded by tides, and lensed by geometry, and if you are stubborn, you will learn to live by it, leaving signals across the spectrum for anyone, anywhere in the island of lamps, who knows how to read a beat drawn by gravity. Astronomers often describe NGC 3414 as a cosmic chameleon, a galaxy that refuses to fit neatly into the tidy boxes of classification. Unlike the elegant spirals with their graceful arms or the smooth featureless ellipses, this system blends traits from multiple families, earning its reputation as a mutant of the galactic world. At first glance, it appears lenticular, a disc-like structure with a central bulge, yet its surrounding halo and tidal debris tell the story of violent encounters. Streams of faint stars arc outward like ghostly fingerprints of past mergers, wrapping the galaxy in a cloak of distortion that betrays a turbulent history. This stellar hybrid, sometimes called the peculiar lens, lies about 80 million light-years away in Leo. Its light, stretched across eons, carries encoded memories of collisions and assimilations that transformed it into the odd form we see today. Deep exposures reveal tidal shells and arcs, ripple-like structures that are the scars of swallowed companions. Such features suggest that the galaxy has feasted on smaller neighbors, pulling them apart with tidal gravity, weaving their stars into elongated filaments that glow faintly against the cosmic background. Unlike the majestic order of spiral arms, the body of this galactic anomaly is chaotic and asymmetric, its dust lanes warped and its stellar distribution uneven. Its nucleus is classified as a liner, a low-ionization nuclear emission line region, indicating the presence of a central black hole quietly accreting material. This weakly active core may not blaze like the quasars of more violent galaxies, but it hints at a restless heart still digesting matter from its disrupted environment. The result is a galaxy suspended between states, not entirely quiescent, not violently active, a liminal form in the evolutionary spectrum. The strange identity of this cosmic outlier makes it invaluable for science. It is a living fossil of galactic transformation, showing how mergers can twist orderly spirals into lenticular remnants, and how cannibalism reshapes structure and destiny. When telescopes peer deeper, they uncover knots of younger stars mingled with ancient populations, signs that bursts of star formation ignited during collisions before slowly fading into silence. Around it, filigrees of stellar streams whisper of interactions still unresolved, as if the galaxy carries its past as luminous trails etched into space. This distorted lens of stars, sometimes nicknamed the Misfit of Leo, lives within a modest galactic neighborhood but stands out as one of its strangest inhabitants. While many galaxies in the Leo constellation present the elegance of spirals or the quiet roundness of ellipticals, this hybrid is a patchwork of dynamical experiments. Observations with the Hubble Space Telescope and ground-based instruments have revealed its faint stellar streams and shells stretching outward like the fading echoes of a symphony. These loops are fossil records of accretion events, frozen ripples on a galactic pond stirred by gravitational intruders long ago. Kinematics show that the stars inside this cosmic renegade do not move with the smooth coherence seen in typical disks. Instead, their orbits are scrambled, some locked into rotating streams, others drifting chaotically, reflecting the scars of disruption. This complex internal structure suggests a violent reshaping not billions of years ago but in relatively recent cosmic times, leaving the galaxy still settling into equilibrium. The dark matter halo that envelopes it provides the invisible scaffolding for these distortions, binding together both native stars and the captured remnants of smaller systems. Astronomers consider this enigmatic lens a case study in how mergers alter galactic destiny. Spirals can be stripped of their arms, their gas reservoirs stirred into turbulence, their cores ignited with transient activity. In the aftermath, what remains is often a smooth lenticular body, but in this mutant form, the transition is unfinished, the process laid bare. By studying its structure, scientists glimpse the pathways by which orderly spirals are transformed into more spheroidal systems, linking the stages of cosmic evolution. Despite its chaotic past, the galaxy continues to harbor a central supermassive black hole. Spectra of its nucleus show signs of ionized gas and low-level accretion, like embers smoldering in the ashes of earlier conflagrations. This central engine may once have been more luminous, possibly triggered during one of its mergers, but now it glows faintly, a whisper rather than a roar. Around it, older stars dominate, painting the galaxy with the redder tones of ancient populations, though patches of bluer light betray younger stars born from merger-driven starbursts. In the realm of peculiar galaxies, this cosmic shapeshifter has earned a place alongside some of the strangest examples known to astronomy. Much like Centaurus A, with its warped dust lanes and enormous radio lobes, or Hoag's object with its near-perfect ring, the Leo mutant is a reminder that the universe does not follow simple templates. Galaxies are not static portraits, they are dynamic beings, constantly sculpted by the forces of gravity, time, and interaction. This hybrid system demonstrates that the neat categories of spiral, elliptical, and lenticular are only snapshots in a continuum of transformation. One of the most striking features of this oddball is the set of faint stellar shells that wrap around it like the layers of an onion. These shells are created when a smaller galaxy plunges into a larger one, its stars flung into radial orbits that pile up at certain distances, forming arcs of light. Over time, these shells dissolve into the background, but while they persist, they serve as archaeological clues to ancient cannibalism. In this way, the galaxy resembles Centaurus A or NGC 3923, other systems famous for their rippling stellar cocoons. Such structures not only reveal the violence of past encounters but also provide laboratories for testing simulations of galactic dynamics. The dark matter halo surrounding this cosmic anomaly plays a hidden but crucial role in its story. Though invisible, this halo acts as the silent architect of the galaxy's fate, dictating how mergers unfold and how tidal streams are preserved. When smaller galaxies are torn apart, their stars become luminous tracers of the underlying gravitational field. By mapping these faint arcs, astronomers gain indirect glimpses of the dark scaffolding that cannot be seen directly. In the case of this peculiar system, the survival of such structures suggests that its halo is both massive and extended, capable of catching and holding on to debris for billions of years. Comparisons to polar ring galaxies highlight another layer of its strangeness. In some images, the faint arcs of light encircling this object almost resemble the beginnings of a misaligned disk, hinting that one of its encounters may have involved the accretion of gas at an odd angle. Polar rings, such as those in NGC 4650A or NGC 2685, show how material can be captured and stabilized in perpendicular orbits, forming rare geometrical wonders. Though the Leo mutant does not possess such a grand ring, the chaotic trails of stars around it suggest a kinship with those more exotic specimens. The central bulge of this galaxy is another mystery. Photometric studies reveal that its brightness profile does not align cleanly with a simple disk or spheroid, but with a hybrid of both. This central light distribution, combined with its kinematically disturbed stars, confirms that it is not a settled system. Instead, it exists in a transitional state, a bridge between youthful spirals and the smoother lenticulars that dominate older galaxy clusters. Observing such an object is like catching a caterpillar mid-metamorphosis, its body reshaping before it hardens into a more permanent form. Its nucleus, classified as a liner, gives astronomers further intrigue. Liners are often associated with aging galaxies whose central black holes accrete at low levels. In this case, the faint emission lines suggest that gas stripped from companions has been funneled inward, feeding the black hole at a gentle pace. The result is a galaxy whose core whispers of activity but never screams like a quasar. Yet, even in its subdued state, the nucleus influences its surroundings, heating gas, ionizing clouds, and leaving subtle fingerprints across the spectrum. Taken together, the evidence paints this peculiar galaxy as a survivor, a system that has endured repeated collisions, absorbed smaller neighbors, and reshaped itself into something that defies easy classification. Its story is written across multiple layers: faint shells, twisted dust, disturbed orbits, and a restless nucleus. Each of these features is a sentence in a cosmic chronicle of change, reminding us that the grand narrative of the universe is one of continual transformation. Seen through deep exposures, the Leo renegade looks like a memory in the act of forming. Its main body is smooth and lens-like, yet the outskirts are stitched with gauzy arcs and folded ripples, the kind of low-surface brightness structures that only appear when a larger system swallows smaller ones and the stars from the victim stack up along shared turning points. Each arc is a kinematic breadcrumb. Follow enough of them and you can infer not only the mass distribution of the host but the timing of the encounter that made the ripple. Computer experiments that throw dwarf galaxies into more massive disks reproduce the same onion skin geometry, and the same slow fading as dynamical mixing erases sharp edges over a few orbital periods. From the center outward, this lenticular misfit refuses to behave like a settled disk. Long-slit and integral field maps of starlight show that the velocity field twists as you move away from the nucleus, as if different generations of stars remember different rules. Some orbits are nearly circular, others plunging and elongated, and the misalignment between the photometric axis and the kinematic axis hints at a triaxial potential, a not quite round gravitational well shaped by past mergers. In places where faint dust threads cross the bulge, the absorption lanes tilt relative to the main body, a telltale of gas arriving from odd angles rather than condensing peacefully in the original plane. The shell-draped enigma carries a nucleus whose spectrum fits the liner archetype, emission lines from low ionization species that advertise a central engine accreting modestly. That engine is almost certainly a supermassive black hole scaled to the galaxy's central velocity dispersion, a quiet heavyweight more ember than bonfire. Even at a subdued pace, such a core can stir its surroundings, ionizing residual gas, nudging pressure balances, and subtly regulating any leftover star formation that merger shocks once ignited. star formation histories extracted from absorption features suggest a mosaic, an old, metal-rich population that dominates the luminosity budget, laced with pockets of intermediate-age stars likely born when infalling gas was shocked and compressed. Ultraviolet imaging of the tidal debris often reveals the last sparks of those episodes, blue pinpricks scattered along the streams like campfires in a desert after the festival has ended. The gas reservoir today is meager, typical for transformed disks. Whatever cold material remained after the skirmishes was either consumed in brief starbursts, heated, or expelled. As a laboratory for dynamics, this Leo outlier is unusually generous. The spacing of its shells encodes the gravitational potential, the thickness of each arc traces phase-mixing timescales, and the brightness contrast between adjacent ripples constrains the mass ratio of the encounter. Where the stellar streams curve, planetary nebulae and globular clusters can be used as test particles, measure their velocities and you sketch the invisible scaffolding of dark matter. The resulting portrait tends to favor a massive, extended halo, exactly the kind of structure that can catch and preserve tidal debris for gigayears rather than letting it vaporize into the background. The kinematically tangled waif does not live alone. It sits in a modest association where slow encounters are plausible, the sort of environment in which repeated minor mergers, rather than a single catastrophic smash-up, can gradually erase spiral architecture. In such neighborhoods, galaxies age not by isolation but by assimilation, trading angular momentum for random motion until the original disk forgets its symmetry. The current morphology, smooth core, warped dust, ghostly skirts, looks like a snapshot taken partway through that assimilation, a chrysalis rather than a final form. Compared with canonical peculiar systems, the tidal alchemist is more understated than a classic polar ring showpiece yet more unruly than a pristine S0. It shares with Centaurus A the language of shells and with NGC 2685 the suggestion that matter can arrive on misaligned orbits, but it translates those dialects into a quieter script. Where some galaxies advertise their strangeness with neon, this one writes in graphite and fog. That subtlety is an advantage. The fainter the structures, the more faithfully they remember the past, because they have not yet been stirred beyond recognition. On the theoretical side, the chimeric lens is a stress test for simulations that track both stars and gas. Reproducing its mixed kinematics demands more than a single head-on collision. You need a sequence where angular momenta don't line up, where gas is fed inward in bursts, and where feedback from the nucleus never quite detonates into a full-scale quasar phase. N-body plus hydrodynamic runs that sprinkle in minor satellites on inclined orbits yield the right combination of warped dust, counter-rotating patches, and shell spacing. They also predict a slowly rising central mass-to-light ratio as older, redder stars dominate, consistent with the galaxy's muted colors. Zoom in, and the accretion-sculpted remnant speaks in chemistry as well as motion. Metallicity gradients flatten wherever tidal stirring has mixed the disk, while localized bumps in alpha element ratios mark locations where short, intense starbursts once spiked the enrichment. Even the dust tells on itself, its grain size distribution shifts after shocks, leaving fingerprints in the far infrared that observers use to time the last major disturbance. If the dust lanes look threadbare now, that is because turbulence long ago shredded the larger clouds and left behind finer, more homogeneously mixed debris. The misaligned relic is also a reminder of how black holes and bulges coevolve outside the spotlight of luminous AGN. In a system like this, accretion proceeds in sips rather than gulps. Over long spans, those sips still matter. They keep the central engine warm enough to ionize gas and perhaps launch weak, thermally driven outflows that prevent the immediate recollapse of any cooled material. Such gentle maintenance, feedback in soft focus, can explain why the present-day star formation rate is low without invoking a dramatic blowout. Out in the fringe, the halo carries a second archive, the globular cluster system. Blue, metal-poor clusters often trace an ancient backbone assembled early, while red, metal-rich clusters shadow the bulge and any subsequent starbursts. Count them, map their orbits, and you can read which components were born in situ and which were adopted. In many transformed disks, the outer cluster system is kinematically hotter than the inner one, as if the outskirts remember the jostling hands of mergers more vividly than the core does. The same logic likely applies here, reinforcing the picture of a galaxy stitched from many smaller stories. For observers, the shell-ringed paradox is a challenge in contrast. Its most revealing features hover barely above the night sky's glow. Amateur telescopes under pristine conditions can tease out the brighter arcs, but it takes long integrations on large apertures, or the surgical sharpness of space telescopes, to chart the full lattice of debris. Each added hour of exposure is like brushing away another layer of dust on a fossil. Contours sharpen, new ripples emerge, and the past becomes less hypothetical. As a signpost for cosmic futures, the hybrid outcast offers a quiet prophecy. Given enough time and enough minor accretions, even well-ordered spirals can relax into smooth, gas-poor lenses. Our own Milky Way, destined to tangle with Andromeda, will not end up identical to this object, yet the broad arc of transformation, disks heated, orbits randomized, nuclei fed episodically, echoes the same theme. Galaxies are biographies written by gravity. This one just left more of its drafts in the margins. In the end, the Leo anomaly is compelling precisely because it is unfinished. Its shells have not yet dissolved into invisibility, its kinematics have not yet aligned into a single, forgetful equilibrium, and its core has not yet gone completely dark. It is a living time machine that lets astronomers watch metamorphosis mid-spell, a place where the tidy textbook sequence of spiral lenticular elliptical blurs into a richer grammar. To study it is to admit that the universe edits constantly, and that the most truthful portraits of galaxies are sketched while the paint is still wet. Push the exposure deeper and the misfit of Leo turns into a tidal palimpsest. What looks smooth at casual glance resolves into an embroidery of structures riding on different clocks, inner stars that complete an orbit in a few 100 million years, outer streams that need billions, and shells whose edges sharpen where those clocks momentarily synchronize. In simulations, this phase wrapping produces the same nested arcs seen around the lenticular chimera, with their spacing quietly encoding the mass profile of the host. Read them carefully and you extract the history, how radial the intruder's plunge was, how massive the encounter, how long ago the splashdown happened. Integral field spectroscopy paints the wayward lens as a kinematic jigsaw. Inside one effective radius the velocity field twists, and beyond it the dispersion swells where overlapping orbit families crowd together. It is the signature of a triaxial potential. The gravity well is neither perfectly round nor simply disk-like, and of stars inherited from multiple progenitors. Some patches even look like a kinematically decoupled core, a central enclave whose stars rotate on a misaligned axis, the fossil of gas that once streamed in along a tilted plane, formed stars, and froze its own memory into motion. In places, the ionized gas refuses to follow the stars at all, preferring orbits set by the last accretion event. That misalignment is dynamical graffiti left by merger geometry rather than calm, in-plane cooling. Across the spectrum the shell-draped enigma keeps yielding clues. In the ultraviolet, faint beads of recent star formation hang along debris where shocks briefly compressed gas. In the mid-infrared the dust glow is modest, suggesting the remaining cold reservoir is thin, typical for transformed disks whose gas was either consumed in merger-triggered bursts or heated and stirred beyond easy collapse. At 21 centimeters, extended neutral hydrogen is scarce or displaced, another hint that tides and ram pressure from the local medium have rearranged the pantry. X-ray images mostly show the pointiest light of old binaries with perhaps a whisper of soft diffuse gas, nothing like a blazing, cluster-scale atmosphere, consistent with a system evolving by slow, repeated nibbles rather than a single cataclysmic smash. Spectral fingerprints turn the tidal paradox into a population mosaic. Lick index measurements and full spectrum fits describe an old, metal-rich backbone with supersolar, alpha/Fe, near the center, evidence for brief, intense star formation long ago, overlaid by intermediate age pockets in the outskirts where streams cross. Metallicity gradients are flatter than you'd expect for an untouched spiral, as if a cosmic spoon had stirred the pot. Where shocks once tore through clouds, alpha elements spike in tiny plateaus. Where dust lanes have thinned, the far IR slope hints at grain processing by turbulence and time. At the very heart, the peculiar lens hosts a restrained engine. Its nucleus wears the badge of a liner, low ionization lines that point to a supermassive black hole accreting in sips. That is enough to keep ambient gas warm, discourage wholesale cooling, and sustain low-level outflows, but not enough to ignite a quasar. Maintenance mode, not demolition. Over gigayears, such gentle feedback can explain why the present star formation rate is low without invoking a dramatic blowout. The center stays just energetic enough to prevent a full reset. The halo is the true archivist. Globular clusters orbit through the outskirts as bright, countable tracers. The blue, metal-poor population maps the ancient framework assembled early, while red, metal-rich clusters echo later, more dissipative episodes. Measure their velocities and you weigh the dark matter scaffolding that cradles the entire structure. Planetary nebulae offer a second set of beacons. Their narrow oxygen lines are easy to catch against the night, letting astronomers chart the velocity field far beyond where starlight alone is practical. Stitch those measurements together with Jeans or Schwarzschild models and a consistent picture emerges, an extended halo that is massive enough to keep tidal debris coherent for a long time, but not so deep that all signatures are erased quickly by violent relaxation. Environment sets the tempo for this oddling. It inhabits a small association where galaxy-galaxy speeds are modest, the perfect breeding ground for repeated minor mergers, harassment, and slow gas starvation. In such neighborhoods, disks fade not by loneliness but by assimilation. Interactions trade ordered rotation for random motion, thicken the stellar body, and exhaust or heat the gas that would otherwise build fresh arms. The result is precisely this half-remembered disk, a whirlless body with a smooth face and a haunted periphery. For observers, the tidal palimpsest demands patience and craft. Its most telling structures hover at surface brightnesses fainter than 28 to 29 mag arcsec superscript 2, where imperfect flat fielding, scattered light, and sky subtraction can forge false ghosts or erase true ones. Long integrations, careful dithers, and aggressive control of internal reflections are not optional but existential. Each additional hour of exposure peels back another layer. Arcs that were guesses turn into curves you can trace, and streams you suspected become highways for kinematic probes. On the theoretical side, the chimeric S0 is a truth serum for simulations. It resists explanation by a single, head-on merger, reproducing the mixed kinematics, misaligned gas, and shell geometry usually requires a sequence of encounters with varied orbits and mass ratios. Hydrodynamic runs that dribble in satellites along inclined paths naturally yield warped dust, counter-rotating pockets, and a liner-like nucleus that never quite tips into a high accretion phase. They also predict a slow, inside-out rise in mass-to-light ratio as aging stars dominate, just what the muted colors and elevated central dispersions imply. Even timing the last big disturbance is possible if you take the cosmic seismology seriously. Shell edges sharpen where stars on radial orbits pile up at apicenter, the spacing between them scales with the orbital period in the host potential. Fit that spacing, fold in the observed dispersion, and you get a clock that reads, a few dynamical times ago. Not yesterday on cosmic scales, but not so ancient that phase mixing has dissolved the evidence. That intermediate age is precisely why the wayward lens is so instructive. We catch it in mid-metamorphosis rather than eulogizing a finished form. Projecting forward, the rippled relic's fate is quiet convergence. As the brightest streams dissolve into the background and any remaining gas trickles inward or drifts away, the body will settle into a smoother, more forgetful lenticular. The nucleus may dim further, the metallicity gradient may continue to flatten, and the kinematic twists may relax toward a single dominant axis. Decades from now in telescope time, but hundreds of millions of years on the galaxy's clock, the misfit of Leo will look less like a confession and more like a polished alibi. Yet for now, the tidal palimpsest keeps its marginalia intact. It reminds us that morphology is grammar, not law, that dark matter is the silent author whose plot is revealed by the orbits of faint tracers, that black holes can shepherd evolution with a nudge rather than a blast. Above all, it shows that galaxies are not categories but biographies. The peculiar lens is a chapter where the handwriting changes mid-page, where edits and crossings out are still visible, where the meaning is richest precisely because the story is unfinished. Push closer to the threshold of darkness and the Leo chimera reveals subtler signatures, isophotes that twist with radius, a quiet cue that the underlying mass is triaxial, and a faint skewness in the light profile where shells pass behind the main body and briefly brighten its outskirts. Photometric decompositions that try to force this rebel into tidy bulged disk molds inevitably leave structured residuals, the image processing equivalent of a raised eyebrow. Subtract a smooth model and the page margins fill with handwriting, arcs, spurs, and wisps, none of which belong to a settled, razor-thin disk. Even the central brightness slope resists a single textbook Circic curve, as though different epochs of assembly have stacked their own layers of starlight, each with a distinct memory for how steep or shallow a galaxy ought to be. In kinematic space, the chimeric lens behaves like a city built over older cities. Cold, nearly circular orbits course through parts of the inner body, but only a few hundred parsecs away the velocity ellipsoid fattens, and random motions dominate. The misalignment between the photometric major axis and the rotation axis is a smoking gun. The potential is not axisymmetric, and some stars are streaming along paths inherited from progenitors that approached on inclined or even polar tracks. Where ionized gas survives, it draws its own map, sometimes counter-rotating, sometimes nearly at rest, an honest cartographer of the last gas-rich accretion rather than a faithful follower of the stellar streaks. Multi-wavelength views keep deepening the portrait. Far ultraviolet pinpricks mark the places where merger shocks briefly compacted gas into dense knots, now fading toward quiescence. In the near-infrared, the old, red backbone dominates, unveiling the true shape of the stellar mass without the cosmetic noise of short-lived blue stars. At longer infrared wavelengths, the dust continuum is soft and unassuming, more ember than flame, consistent with a pantry largely emptied by past starbursts or heated into a phase reluctant to collapse. Radio maps at 21 centimeters struggle to find a grand reservoir. Any neutral hydrogen that remains appears scant, rearranged, or exiled to the periphery by tides. Treat the misfit of Leo as a seismograph and the shell pattern becomes a timepiece. Stars launched onto radial orbits during a merger pile up at apocenter, their densities cresting into nested arcs whose spacing reflects the host's mass profile and the time since impact. Measure those intervals, fold them through dynamical models, and an era emerges, not so young that the debris is razor-sharp, not so old that the ripples have fully dissolved, an in-between age where phase wrapping is vivid and instructive. In that window, even small differences in shell curvature and thickness reveal whether the intruder arrived headlong or skirted in on a grazing pass. The hybrid's globular cluster system adds footnotes to the chronicle. Blue, metal-poor clusters roam far out, relics of the earliest scaffolding assembled when the universe was denser and rougher. Red, metal-rich siblings huddle closer to the bulge, echoing later, dissipative episodes when gas pooled and formed stars in surges. Their velocities, easy to sample with narrowband filters and efficient spectrographs, become tracer bullets for the dark matter halo. Stitch cluster and planetary nebula kinematics into genes or orbit superposition models and the invisible architecture takes shape, an extended halo that is deep enough to keep streams coherent for gigayears, yet not so violent as to erase their memory overnight. If the lens-shaped renegade once hosted a bar, hints of that past may linger in subtleties, boxy isophotes, faint X-shapes in the residual light, or small, sigma drops where bar-driven inflows cooled and formed stars with unusually ordered motions. Even without a surviving bar, the consequences of past